Okay, so we left off in this problem right here, and let's go ahead and start working on it. Let's go ahead and start working. So we know how long ABD is. It's just 5y plus 2. However long the whole entire line is, the whole entire angle of ABC is 8y plus 10. But we don't know this middle section right here, and we're asked to find the measure of angle DBC. We're trying to look for this angle right here. What you notice, what's different about these problems from the last problems is that they involve a variable. And do you remember from 1-2, when do we solve for a variable? You're usually asked to solve for a variable when we were dealing with length, distance, and however long a segment was. And so it's the same case here. So let's go ahead and use our formula up here. So our postulate, I mean. So measure of DBC. So measure of angle DBC. And so what other part makes up the whole entire angle? ABD. So the measure of angle ABD plus measure of angle DBC is equal to however long the whole entire angle is. So the measure of ABC, which is 8y plus 10. So let's find out how long. We already had given us two parts, so let's go ahead and plug it in. So ABD 5y plus 2 degrees plus measure of DBC. We don't know what that is because that's what we're looking for. Sorry. DBC. And 8y plus 10. Then this should have been the measure of ABC. Okay, so then let's go ahead and solve for a measure of angle DBC. So minus 5y minus 2 minus 5y minus 2. So over here we're left over with the measure of angle DBC, and over here gets canceled. Everything over here gets canceled. So the measure of angle DBC is equal to 3y plus 8. And for that one, we have the measure of DBC. The measure of DBC is equal to 3y plus 8. So 3y plus 8. Now that's one part. Okay, so there you go. Measure of angle DBC is equal to 3y plus 8. But we're looking for the degrees of it. We don't know what the degrees are. They just give us an expression here. So when it says bisect, this part up here should equal to this part down here. So what we're going to do is we're going to go ahead and set those both equal to each other. 5y plus 2 is equal to 3y plus 8, because the measure of angle ABD is congruent to the measure of angle DBC. So let's go ahead and solve for y. So minus 3y minus 3y. So we have 2y plus 2 equals 8. Minus 2 minus 2. 2y equals 6. So let's cancel out. Divided by 2. So we have y is equal to 6. So let's go ahead and plug that back into our equation for finding DBC, which is 3y plus 8. So let's plug this back into here. So I'm running out of space. So the measure of angle DBC is equal to 3y plus 8. 3 times 6 plus 8. So it would be 18 plus 8, which equals 26 degrees. DBC. Okay, it looks like a lot of work, but just keep going through with it. I'll be looking for the process that you're able to understand. So the measure of DBC, of angle DBC, is equal to 26. Is equal to 26 degrees. Okay. Now the last one shouldn't be that bad. we have MR bisects LMO, so let's go ahead and draw that one. LMO, and MR bisects it. Then we're going to go ahead and put in LMR. LMR is equal to 5y plus 2. And then RMO. RMO is equal to 2y plus 29. And it's asking for LMR. 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 For this part right here. LMR. So what you need to do here is go ahead and use what we already know. What can you apply from the top part in comparison to the bottom part? They're both congruent. Okay, so let's go ahead and go with M. Measure M. LMR is congruent to the measure of angle RMO. So LMR will be 5y plus 2, which is equal to RMO, which is 2y plus 29. So let's go ahead and solve for y here. So minus 2y, which is crosses out, 29, 3y plus 2. So let's go ahead and subtract 2. So you get 3y equals 27 divided by 3. Y is equal to 9 from there. So you go ahead and plug that back into LMR. LMR, which is 5y plus 2. So you get 5 times 9 plus 2, which is equal to 45 plus 2, which is equals 47. Okay? So I know I went a little bit fast there. My time's running out on this one, so